All right, here we go. Hi, everybody. Today, I'd just like to go over a few acronyms for those who aren't familiar with 3D printing or additive manufacturing, so they can get used to the words and phrases I'm going to be using through my YouTube series. And It's been my practice that not everybody is aware of all the terminology used and all the different practices that are involved with additive manufacturing or 3D printing, and those two terms alone kind of say all this really needs to be said about it. People don't understand that 3D printing and additive manufacturing are the same thing. The 3D printing is the hot keyword. Additive manufacturing is more of an industry term for companies that are using it as part of their manufacturing process. So when you hear additive manufacturing and 3D printing, they're kind of interchangeable, but there are a lot of acronyms you need to be aware of. So first, we'll start with CAD, C-A-D, and CAD is the file that you create, or the program that you use to create a file that will be used for the additive manufacturing or 3D printing machine. And CAD stands for computer aided design. It used to be computer aided drafting back in the 90s or so, when drafting was still strong, and they're not really teaching drafting that much in schools nowadays. Is kind of a sticking point for me. Coming from a CAD background, a drafting background. And there's two types of CAD. There's 3D CAD, and then there's 2D CAD. D for dimension, so 3-dimensional or 2-dimensional. So 3-dimensional CAD is what you need for a 3-dimensional model that will eventually go into a machine, and that'll eventually print you your part. And 2D CAD, which is still around. There's still a lot of programs that do 2D straight CAD. Is only 2 dimensions. It's kind of like drawing on a sheet of paper, except it's electronic. And there's a lot of programs that add value to that, so you can create your 2D profiles. There's actually a Shapeways application, I think, where you take a 2D sketch and it'll extrude it for you to make items for you. So there's applications that'll take like a Photoshop 2D print and then use that as a basis. So some of the programs you might want to keep in mind for 3D and 2D, and again, I'm not not again for the first time. I'm going to say this. I'm not sponsored by any of these 3D companies, these CAD application companies. I'm actually a user group leader for one, but I'm not using it for my business. I'm using Moto 801 for my business because I own a seat of that. But there are some freeware applications that I'm trying out. So the players of the game, the biggest players are AutoCAD, Fusion 360, Inventor. They're heavy in the 2D world. They're just the 600-pound gorilla. And then you have SolidWorks, ZBrush, TinkerCAD, and again Moto. Let's see, and Photoshop, it can actually do 3D modeling as well to some extent, what I'm told, and what I've read. So you can actually take profiles, vector profiles, and extrude them and create what we're going to get to next, which is the next acronym, which is STL. So STL is the file extension of whatever CAD package you're using. You need to get your file to a .stl, kind of like how your Microsoft Word is a .dox or .cx or whatever. You need to have a program that can make an STL file. And STL is standard tessellation language, and the file extension itself doesn't have a native program, but all the programs can save to it. So it's really important to know, or I shouldn't say all programs, but most. I haven't yet to run in a 3D program that can't do an STL, so it seems like a basic common denominator. But you should check into it if you're going to be doing 3D printing. Make sure you have a CAD package. It can make an STL file so that you can push it to your 3D printer. So So, and then you have the 3D printing, which is three-dimensional printing, and AM, which is additive manufacturing. For me, they're the same thing. So some people take exception to that, and they say there are differences. But additive manufacturing, you're creating things by building up, not subtractive manufacturing, as you know, you're machining or whatnot, machining things away. In this case, you're building things up. So there's several different variations of that too, and we're going to go over them. There are, you know, let's see, two major types. There's the extrusion type 3D printing, and there's the vat, building up from a vat 3D printing. So where you have a medium inside of a vat, and then you're using a laser or a light or electron beam or something like that to build up layers. So you have, you know, layer by layer by layer of designs, and then you get a cake of your print, and then depending on, you know, what areas of those layers that you sintered together or melted together, that becomes your print. So, and the first one's going to be SLA, so stereolithography. It's been around since 1986, and only in the past 3 or 5 years or so, it's become, you know, well known for. But in the industry, it's been around for a really long time. I think it's, you know, the patents have kind of matured, and or the, you know, the process has gotten, you know, closer to consumer. So SLA, that's when you take like a vat of goop, so it's more or less as a vat of chemicals, and cure layers by UV or light, and then you have a mechanism bringing up out of the goop, you know, that first layer up by like, you know, like 0.04, you know, micron, or 0.4 microns or so, or a couple thousandths of an inch, and then the light hits it on the bottom to create another layer, and raises up, and as the goop, you know, gets underneath of it builds up the layers that way. So it kind of looks like it's growing out of the pit. So kind of ominous, but it's kind of cool too. So the kind of brother to that, or the sibling to that, is selective laser sintering, which is, you have instead of a vat of goop, you have a basin of powder, and you're taking a laser, and you're fusing the pattern in the powder, and then you pass on another layer of powder, and then you laser it on another set. So as you're building up every, you know, layer, you're creating another fused portion of that. So then that infuses not only to the molecules to the sides, but the molecules to the original fused model. So you end up building something up by layers that way, kind of like Legos. So, also not a sponsor. And then you get into some nuances where you have SLM, which is selective laser melting, which is a more in-depth version of SLS, where you're taking, you know, the molecules, and you're throwing so much energy at it, you can actually start adjusting or doing interesting things with the molecular structure. So I'm looking forward to seeing material sciences move forward with that, and creating some pretty interesting things with, you know, materials, when you shoot as much energy as you need into it, and you do composite, you know, materials, and try to get interesting results. It should be, you know, it should be something that the industry looks into greatly, and where I think a lot of the money is right now is material science. So and another subset of that is EBM, which is electron beam melting. So that's, instead of using a laser, using an electron beam, really high power. So you're doing some interesting stuff at that point. I'm not sure. You know, maybe it's for I believe it's for like the higher heat metals, or you know, because there are stainless steels that are readily available for additive manufacturing, but then you have higher heat metals like Inconels and things like that. I mean, I'm not sure if they need electrical beam melting or electron beam melting or not. But it's the same, essentially the same idea. You take a bed of powder, you go over it, make your layer, more powder layer, and you just do the same thing. And And for the last one I'll go over in this episode is FDM, and that's probably the most popular one that you see in the stores. You'll see the maker bots over at like Costco or something like that nowadays, or Staples, and then you go to Home Depot and you have the Dremel. You know, those are the ones that they're not the vat ones; those are the extruder ones. So they're taking like a string of plastic, putting it through a heating element, and then turning it into not liquid, uh, not totally liquid, but just soft enough so it'll come out uh, like a pastry cake squeezer. So you're creating very very tiny, uh, uh, how should I put it, a stream of plastic, and you're able to create your layers that way. And then, but you do have to have in some cases you need a heated pad so it doesn't cool too quickly. So in this point, there's just the plastic and air. So your heating arrangement needs to be addressed. So some 3D printers need to be in a enclosed environment. Some don't have to. So, but FDM is fused deposition modeling, FDM. So and that was, I think, patented back in 1980. And also patent the acronym is actually patented, I think, by Stratasys. So you'll see other companies use FFF, which is fused filament fabrication. So, but FFF and FDM are essentially the same thing. Just one's patent, one's the Xerox name of it, and the other one is not. So, but there are, Stratasys and 3D, I think, 3D Systems, I think, are the players in the game. And right now, you have all the other ones who have to use the, FFF. So, so I'll list the acronyms and the names below, and you can just wiki them. They're all over the place. I mean, there's a lot of additive manufacturing information available now, but I just want to make sure that as I go forward, people who are new to it, people who've never seen it, or they're not aware of all what the different terms mean, because that's the kind of like the gating item for some people that they don't want to get involved because they don't understand. And just getting back to the basics and what the acronyms are and what people are talking about with all these 3-letter words. So so I hope you found that useful, and I'll try to leave as many links as I can down below. And you have a great one. All right, I'll see you next week.